Let's take a few minutes and look at the solutions to this probability-free response question. So in part A, given that a randomly selected registered voter is male, so here's the conditional component of that probability, what's the probability that he is registered for party Y? Well, given that the voter is male, so I can only look at the row involving males, there are 48 males out of 200 that are registered for party Y. So it's important, make sure you either describe it in words as question A does, or use probability notation in order to label your probability. Don't just put 0.24. Don't just write the fraction, although the fraction is important because it represents your work. Make sure that that probability is labeled. Don't leave the answer bald. In other words, don't leave the answer without any context at all. So that's part A. So for part B, among the registered voters in this township, are the events is a male and is registered for party Y? Are they independent? So this is a yes or no question. So notice I put my answer of no right there. Justify your answer based on probabilities calculated from this table. So you have to have evidence in terms of the probabilities. You can't just write an answer where you tell some type of a story. No, we have data, so we need to use the data to justify our conclusion. So something to think about. I said no, the events is a male and is registered for party Y are not independent among the registered voters of Franklin Township. I essentially just copied the words. So now think about this. To be independent, the probability of being registered for party Y. So that's the plain probability of being registered for party Y. And the probability of being registered for party Y, given that the voter is male. That's the calculated probability here. Being registered for party Y, given that the voter is male, those should be the same. So to be independent, being a male voter should have no impact on the probability that a voter is registered for party Y. But notice they're not the same. So here, under the condition that the voter is male, the probability of being registered for party Y is 0.24. I'm just recycling that answer from part A. But the overall probability of being registered for party Y is 0.366. That's the new probability that I calculated in part B. So in general, being registered for party Y, there are a total of 168 that are registered for party Y out of 500. That's how we calculated that probability there. So understand, I'm showing the two probabilities numerically. Clearly, they're not the same, but I wrote even more specifically. So notice the conditional probability under the condition that someone is male, that actually lowers the likelihood that they are registered for party Y. So if you use a word like increases or lowers, that implies a comparison. That's a comparison vocabulary word. That's why I'm ending my answer with that statement here. Being male lowers the chance that a randomly selected registered voter of Franklin Township is registered for party Y. So I am justifying my answer based on probabilities, and it's the comparison of those probabilities that justifies the no. So for the last part of the question, I included here, this is part C of the question, but all this is doing is showing you this particular bar graph. This is called a segmented bar graph. To actually answer the question, you have to go to the second page. So what I did on the second page, this is the stem of the question again. Here's part C of the question again. So then finally at the very bottom, we get to the location where you need to answer the question. So a different township. In Lawrence Township, the proportion of all registered voters for parties W, X, and Y are the same as for Franklin Township. Okay, so what that means is in Franklin Township, party W represents 88 out of 500 registered voters, so that's 17.6%. Party X is 244 out of 500, so that's 0.488. Party Y, we already know this, it's 168 out of 500, so that's 33.6%, 0.366. And I was just told that the probabilities or the proportions in Lawrence Township for parties W, X, and Y are the same as for Franklin Township. So now I also know I just calculated the proportions for Lawrence Township. But here's the key word. Party registration is independent of gender in Lawrence Township. So complete the bar graph below to show the distribution of party registration by gender in Lawrence Township. So understand, if party registration is independent of gender, if party registrations are independent of gender, then both genders must have the same distribution of party registrations. So it doesn't matter whether someone is randomly selected and happens to be a male or a female, the likelihood of being in Party X, Party Y, or Party Z has to be the same for both genders in Lawrence Township. So we're told these proportions are the same as in Franklin Township. So the proportions are shown at the top of this page as the marginal distribution of party affiliation. So this is a two-way table. Party W, X, and Y at the top, male and female along the side. So every subject is classified in terms of two characteristics, party affiliation and gender. That's why this is called a two-way table. So the totals are here in what we call the margin. So these are the column totals, these are the row totals. So the marginal distribution, I just calculated these percentages by using the totals, and I know those percentages have to be the same for both the males and the females in Lawrence Township because party affiliation is independent of gender. So all I have to do here, Party X has to be 17.6% for both the males and the females. So notice I made a little rectangle here and I shaded it sort of super light gray, if you will. So those bars extend to about approximately where 17.6% would be. So that's Party W. Oh, notice, this is really important. I labeled this incorrectly. Do you see how I've labeled this incorrectly? I labeled this as Party X. Again, I'm thinking of three parties, so I labeled them as X, Y, and Z, but that's incorrect. So notice it's W, X, and Y. So let's relabel this. It's important to describe. It's important to label what you are doing. So here are the party affiliations for W. So back to our table, the party affiliation for X is 48.8%. So what I had to do is I started at 17.6% and I added 48.8%. So 17.6 plus 48.8, that goes to about 66.4. So I needed another rectangle in my bar graph. To have the correct length of about 48.8%, I had to extend it up to where about I would get to 66.4% in total. But notice again, I've labeled these incorrectly. This is for Party X's affiliation, so I should be more careful with my labels. So it's an easy change. There we go. So the last party affiliation is about 33.6%. That's for Party Y. So that has to be the remainder of the bar graph in order to add up to 100% because everyone is classified into one of these three categories. Again, I've labeled it incorrectly. This is supposed to be Party Y, and I labeled it as Party Z. So we'll change that to a Y. There we go. Now it's labeled correctly. And at some level, this part C of the question is tricky in the sense that it's almost so easy that it doesn't seem like that could possibly be the answer. But that's the whole idea behind independence. If we know that events are independent of one another, the truth is that does simplify our life. So in this context, at least it simplifies things when we're doing probability calculations. So in this context, if party affiliation is independent of gender, literally you can see it now in the graph. What that means is that the party affiliations for Party W and Party X and Party Y, they have to be the same for both genders, knowing that a subject that is randomly selected as female or male has no effect on their party affiliation. And you can literally see it because the segments in these two bar graphs are the same.